Welcome back to this video lecture series on data structure and algorithms. Today we'll be seeing the binary search tree and the insertion and search operation. So let's start. So we had already discussed about what a binary search tree is in our introduction part. So basically, to properly define the characteristics of the binary search tree, it has some features and which are constant for any scenarios. So the very first feature is that the left subtree of a node contains only nodes with lesser values. The right subtree of a node contains only nodes with higher values. The left and right subtree each must also be a binary search tree. That each of the subtrees should also abide by the first and second rule, and there must be no duplicate nodes. So in this diagram we can see that all these values that lie in this left subtree of node 8 are having values lesser than 8, and in this right subtree the node values are always greater than this value 8. So this left subtree and this right subtree, again they themselves are a binary search tree. For example, this left subtree, the root node is 3, so the left child is having lesser values, and all the values at the right subtree of this node 3 are having greater values. Also we can see that in this binary search tree there are no two nodes with same data value. Moving forward, we will now discuss about the steps that we are going to take for insertion and search operation. So for insertion operation, the function that we will be invoking all the time, that function will take two arguments. One is the root node of the binary search tree and the key value. Now when we do the operation in the function, we first check whether the root is null or not. If the root is null, then a new node with the key value is returned. Now if the root node value is higher than the key value, then a recursion call of the function is executed on the left child node of the root node. It's very obvious because in binary search tree all the nodes with values lesser than a node lie in the left subtree. So as the key value is lesser than the root node value, we call a recursion on the left child node. And same way, lastly, if the root node value is lesser than the key value, then the recursion call is executed on right child node of the root node. And then comes the search operation on binary search tree. So this function will take the root node and the search key as arguments. If the root is null or the value of the node matches with the search key, then the root node is returned. But if the root node value is higher than the search key, then a recursion call is executed on the left child node of the root node. And if the root node value is lesser than the search key, then a recursion call is executed on right child of the root node. So now let's jump onto the coding part and see how we can implement this insertion and search operation on binary search tree. So I have opened my IDE and here I have already typed down some lines of codes. So these are the functions, the new node function and the in order function that we will be needing here. So I have already just copied them here, and the structure of the node remains same. It has a data field and two pointer fields. So we'll start coding right from here in the main function. So what we'll do, we'll first take a root node, so struct node star root, and we'll assign it with a value of null. Now then we will use the insert function only to initialize the tree making thing. So the arguments to the function will be the root node and the value. So let's say I'm going to start with 25. So here we're going to define the function first. So the return type of the function will be struct node star, then the function name, and the arguments will be struct node star r and let's say val. So here if root node is null, then we'll simply return the new node and the value with the val. Right. Now else if the value is greater than the data value at the root node, so then it will be lying at the right subtree. So r right is equal to insert right comma val. Else if the val is less than r data, so then r left will be then r left and the val. Lastly we'll return the r. So this is the insert function. So like this we will, let's say, insert 20. Let me just copy this line of the code. We'll do this 4 times. So first we'll insert 20, then 30, then let's say 15 and 22. So now we'll have a check that how the tree looks like. So the binary search tree is a new line, and we will use the in order function. Root, and we'll print a new line. Now comes the part of the search. For that I'll actually need a variable called search key and also another node, so result. I'll name it result. So what I'll do, I'll call the search function here, and the arguments will be the root node and the search key. So before that I'll actually print down a line or a message for the user, that is type the value to search in the binary search tree. Then we'll use a scanf here, %d ampersand search key, and then we will operate this search function. So let me just define the search function. Again, the return type will be struct node star. The arguments will be struct node star r, let's say, and let's name it key only. So here the first condition, if the r is null or the r data matches with the key, then will return r. Else if we see that the key is less than the r data, then search in the left subtree. So search, actually this should be like turn r left and the key, and else if key is greater than the r data, then return search r right and the key. Okay, so this is the search function here. Now we'll print down a message that if result is not null, then just print that search successful, and in the else part there will be no condition for else, obviously. So here we'll be saying unsuccessful. So let's now run this program and see how we can implement it. Okay, so we have the result here. So the 25 was the root value, then 20, 30, 15 and 22 was inserted in the binary search tree, and this is the proper in order traversal of the binary search tree. So insertions have been done properly. Now we'll test the search function. So let's say I want to search for 20. So search successful because 20 is in this binary search tree. Now let's run it again and type an value which is not in the binary search tree and see how this function responds. So here now I'm going to enter a value of 21 which is not in the binary search tree, and it says search unsuccessful. So our code is running pretty well. So this was how you can operate the search and insertion function on the binary search tree. Thank you for watching this video and staying with us. See you next time.